All right, next up in 4.5 day 2 is our basic cotangent graphs. A lot of these things are going to be the same in this one as the last example, but there will be a couple subtle differences. Now, the one difference that we'll have to start with is the fact that we know we want to find out where sine is equal to 0. From what we've done with sine in the past and what we did yesterday, sine is going to be 0. Well, one of them is right on the axis right here. So this is going to be one spot where we're going to have a vertical asymptote. Another one's going to be at pi, and another one's going to be at 2 pi. And this, if you're not sure where I'm getting those from, watch yesterday's stuff on cosecant, and you'll see this is just where the sine sketching aid crossed 0, and so we're just putting the same types of vertical asymptotes in for this one. So we get all those vertical lines placed first. Now, like we did in the tangent graph, we're going to construct these branches in a very similar way on this one. So this will go a little bit faster. If you need a slower version, go back to the tangent video and you'll be able to see a little bit slower version. But you'll notice here that we have pi, 2 pi. This right here is going to be pi over 2. And since we've got two vertical asymptotes, we're going to have one full branch in this area. So what I'm going to do is I'm going to put a point smack dab in the middle, because if I did the cotangent of pi over 2, it's going to be equal to 0. You can take a look on the unit circle for that if you're not sure about how I came up with that. But then the next thing I want to do is I want to find out what is the value at pi over 4. Now, as I've talked through these, starting with cosecant and secant yesterday, and then we just did tangent in the last video, we're pretty much always choosing a value between the axis and the midpoint to get our secondary point, or our extra point going on in here. So I'm going to take this pi over 4. As you may remember, it pretty much always comes down to pi over 4 somehow. And then I'm going to put that into cotangent of x. So y equals cotangent of pi over 4. And remember, we figure that out by doing our 45, 45, 90 triangle, where we have square root of 2 over 2, square root of 2 over 2, and 1. And so that means that the cotangent of pi over 4 is adjacent over opposite, so square root of 2 over 2 divided by square root of 2 over 2, which is 1. And again, that's a nice thing to work with. It's really fortunate that we have that easy of a number to use in this problem. And so on this axis then, I can go up to 1, I can mark a point right here. And something that we found with the tangent graph is that it's going to have like this branch that goes from bottom to top or top to bottom. And so what we're going to be able to just, what I'm saying we can just assume here is that this is going to have a symmetric shape on the negative side for this branch. So from here, once we get those 3 dots, then we can connect it and make sure we follow the vertical asymptotes going on there. That gives us one of the branches of this graph. Now, like I've said before, we need to have 2 full periods. I could fill in all of these if I want, but I'm not going to require that you guys do that. So I'll just go over to this one and do one more period for us to have the shape for it. It's going to follow the exact same pattern as the last one, connect the dots, and there we have 2 full periods. So cotangent and tangent, if you know the tricks, they're actually probably a little quicker to do than cosecant or secant. As I mentioned before, the last thing I want you to label in your graph is the point that we found, and this point was just like the last one. It was pi over 4, 1. But notice that this shape is actually the opposite shape of what we had from the previous graph. So this was tangent. You'll notice that it went from down to up in each branch. Here's cotangent, it's going up to down in this case. So they are reflected in a way for these 2 graphs. Now, as I mentioned in the last graph, in the tangent graph, the period here is going to be a little different than what we've seen on the previous graphs before it. This period is also going to be pi. So if we don't do any transformations for a cotangent graph, the period will be pi. That again is different from cosine, sine, cosecant, secant. So I just want to mention that, put that here at the bottom here, that if we have sine or cosine or cosecant or secant, the period for those, at least what we start with, is 2 pi. Okay, that's something that we've done in the past. For tangent and cotangent, know that these are different. The period for these graphs, if you don't have any transformations, is pi. I would write that down, I would put that somewhere because that is a fact that a lot of people forget. I don't want you to forget that fact. So that is our basic cotangent graph. We will go on to do one more graph, a transformed one of these two examples.